This is Honors Algebra 2 Pre-Calc. We are doing section 2.2, and this is our last video in this section. We're doing the definition of rational exponents. So on page 97, you'll see that a is a real number. A is an element of reals, and that a is positive, thus a is greater than 0. For a non-zero n, a to the 1 over n is the same as the nth root of a. So for example, the only root where you don't see a number here is a square root, which implies a 2, right? In every other root, like a cube root or a fourth root, there's a number right here. So for instance, if you wanted to put the square root of x in your calculator and for some reason didn't want to use the square root button, you could do an x caret to the 1/2, right? Or 0.5. For n not equal to 0, a to the m over n can be written in one of two ways, and we're going to walk through in example 5 why one of those ways is better than others in certain circumstances. It can be written as the nth root of the quantity a to the m, or it can be written as the nth root of a whole quantity to the m. Either of those are fine. Now, what we're going to do in E5 is we're going to walk through evaluating some of these without a calculator. So the easiest way to do that, because most of us feel better with roots than we do with rational exponents, is to rewrite this as a root. So let's start with a. 25 to the 1/2 is the same as saying the square root of 25. Well, that's a 5, so cool. And you can confirm that in a calculator by doing a 25 caret and then in parentheses 1/2. Now, 8 to the 4/3 is interesting. I'm going to write it in both of these ways, and I'm going to show you why one is useful and one is not useful. Remember, when you see this, you're probably going to be seeing it in a situation where you have to be able to do this without a calculator, like on an AP test in a non-calculator section. So I can either rewrite 8 to the 4/3 as the third root, right, so cube root of 8 to the 4th. Okay, this is true, but not helpful, right? Just because something is mathematically correct doesn't mean it helps you, right? So for instance, if you get in trouble with your parents for doing something and then out of nowhere you're like, 7 squared is 49. Well, that's true, but unless the thing you got in trouble for was failing a math test, chances are that true mathematical statement didn't do a darn thing to help you from being in trouble with your family. So, true but not helpful. If instead I wrote this way, as the cube root of 8 quantity to the 4th, well, now suddenly this is very useful, because since I did what I suggested a couple videos ago and memorized perfect cubes, I know that the cube root of 8 is a 2. 2 to the 4th is a 16, because I memorized all of those things that people suggested that, I should memorize, right? So hint, hint, wink, wink, nod, nod, memorize some powers. So I get a 16, and you can check that by doing an 8 caret and then in parentheses 4/3. So this would have also gotten me to a 16, but I'm pretty solid at math, and I don't know what 8 to the 4th is. So it's not helpful because 8 to the 4th isn't mental math, right? It's not easy mental math. And the cube root of that huge number is definitely not mental math, right? So the issue is that although this step is correct, right, there's nothing wrong with writing this, I'm 100% right when I write it didn't help me, right? So when you do stuff, sometimes you're going to do things that are mathematically correct but not helpful, and that's super frustrating, but it's an accurate statement, and it would be a lie if I told you that you're always going to do the right thing when you do a problem. Sometimes you're going to do the wrong thing. Sometimes on these videos, you're going to see me do the wrong thing and then say, oh man, wait a sec, let's take it back and do a different thing. I don't usually delete those from my videos, just like I wouldn't cut them out of my lessons in class. I like you to see that sometimes you're going to make mistakes. No matter how good at math you are, sometimes you go the wrong route. Not because it's necessarily mathematically wrong, but because sometimes your logical reasoning takes you down a road that's not helpful. It doesn't have to be wrong to be not helpful. Lots of things can be right and not helpful. All right, so let's walk through C and D, and then I'll let you guys try some in your P5. So 32 to the 3/5. So I can write this in one of two ways. And again, I'm going to show you that one of these ways is not helpful. I can either write this as the 5th root of a 32 cubed. And my brain's like, nope, this is a bad idea, right? I don't know what 32 cubed is, but it's not going to make my life better, that's for sure. Instead, I'm going to write this as a 5th root of 32 whole quantity to the 3rd. Well, I know that 32 is 2 to the 5th because I memorized that list of things that I suggested people memorize. So this is a 2 to the 5th, which means this is going to be the 5th root of 32 will just give me a 2, right? So I get 2 to the 3rd, and my answer is 8. Same thing with the 27 to the 2/3, right? You can write this in one of two ways. And again, I'm not suggesting that you write it in one of two ways. If I were doing this problem, I would just do this, and I would just do this, right? I wouldn't do the other option. So same option here, right? You have the bad option of doing the cube root of 27 squared. Nope, not going to do it. Not going to do 27 squared. That's a terrible idea. But what I could do instead is the cube root of 27 whole quantity squared. Well, I know that 27 is a perfect cube. It's 3 cubed. So I get 3 squared, which means my final answer is a 9, right? So this is what I would do. Again, it's not mathematically wrong to write this step, but it kind of stalls you, and you can't really do anything else after. So I'm going to erase this stuff, and I'm going to give you... I'm going to erase this and give you a P5, right? So, all right, so for P5, give you a similar experience. Same thing, you're going to do this without a calculator, A, B, C, and D. Let's do a 16, let's make it interesting, to the negative 1/2. Let's see what you do with that. Let's do a 9 to the 3/2. Let's do a 64 to the 2/3. And let's do a 16 to the 5/4. Cool. All right. So you can pause me if you want. I'm going to go ahead and walk through it. But yeah. So A was meant to be a little tricky. The first thing to recognize is that 1/2 exponent being negative means, hey, I'm on the wrong floor. So this is 1 over a 16 to the 1/2, which is the same as a 1 over the square root of 16, which is a 1/4. So that was definitely tricky of me. I admit it. 9 to the 3/2, right? I can rewrite this one of two ways, either as a square root of 9 cubed, but that's not going to help me, or as the square root of 9 quantity cubed. That's the smarter way to do it, because I get 3 cubed is a 27, right? Same thing here. I can either rewrite this as a 64 squared and then try to take a cube root, but that's a terrible idea, or I can do the cube root of the 64 and then square it. Well, 64 is 4 to the 3rd, so that's a 4 squared, or a 16, right? And then this 16 to the 5/4, well, I can either write it as 16 to the 5th and then take the 4th root, but that seems like a bad idea, so I'm going to do the 4th root of 16 to the 5th, and I know that 16 is a 2 to the 4th, so I get 2 to the 5th power, which is a 32. So that's kind of the gist. Again, I already threw in one of those negative exponents, but let's just do one or two that are a little trickier. We'll do an E6 just to walk through in case I throw any other tricks at you. So let's do an E6. Same as E5. But just slightly trickier, right? So let's do a couple of these that we're going to evaluate by hand. All right, so let's do, we'll put negative in front of a 32 to the 2/5. Let's do a let's do a 27 to the negative 2/3. Let's do a 1,000, we'll do 10,000, to the negative 2/5. Okay, cool. Let's just try it. I know I did another 5 inadvertently, but that's okay. All right, so let's walk through this. So the first thing I want you to notice is that in that first expression, this is an exponent, and it's being multiplied by a negative, okay? So what I want you to notice is that this is not the same as if I had written negative 32 in parentheses to the 2/5, okay? So that's important, because the the negative is a coefficient that is multiplying this number. It is not the same as if I put a negative inside the 2/5. So that negative is just going to chill out in front, okay? So what's going to happen, sorry, fell asleep. What's going to happen is this negative just chills in front, and I'm going to get that I want the 5th root of 32 all to the 2nd. Well, that's a negative in front of a 2 to the 2nd, which is a -4, right? So the negative really just chills there and doesn't affect my math at all because it's not part of the 32, okay? Now, if the negative had been inside the 32, that'd be a different problem because then the -2 would be squared, right? So the orange problem, just to show you, if I had tried to do the orange problem, I would have gotten the 5th root of a -32 all to the 2nd. Well, that's a -2 to the 2nd, which is a +4. So they're different problems, right? So it really does matter. That notation matters. All right, let's do the 27 to the -2/3. Remember, a negative exponent means, hey, I'm on the wrong floor. So this 27 should be a 27 to the 2/3 on the bottom, right? 1 over 27 to the 2/3. Now I'll go ahead and do my root stuff. That's the cube root of 27 whole quantity squared. So that's a 1 over a 3 squared, or a 1/9. Right? And then when I do this guy, it's a similar problem, right? It's a 1 over the 10,000 to the 2/5, which is a 1 over the 5th root of 10,000. Do I mean 10,000? I didn't. Ignore me. There should be an extra 0. My bad. It wasn't a perfect 5th. Okay. Sorry. My bad. Added this 0 later because I accidentally screwed up, okay? All to the 2nd. My bad, okay. So I get a 1 over, well, this is 10 to the 5th, right? Because hence the 5 zeros. So I get a 10 squared on the bottom, so that's a 1 over 100. And in this case, that's a pretty common decimal if you want to write it as a 1/100th. So my bad, I missed a 0 in my original problem. Sorry, counting is hard sometimes. Okay, so I'm gonna give you a P6, and then we'll pretty much call it a day on this. Okay. So let's do a P6. So P6, same as E5 and P5 and E6, all that stuff. Okay, so I'm gonna put a 2 in front of. Let's do an 8 to the 4/3. And let's do, actually, let's not do a 2. Let's do a 5. Take it back. 5 in front of an 8 to the 4/3. Let's do a 64 to the -1/3. Let's do, you do an 81 to the -3/4. Cool. Let's try those, and then I have a quick challenge problem that we'll try. So actually, I'll just throw the challenge problem out here now. I'm going to give you a challenge. I'm going to ask you to do a 36 to the 6/4. So we'll do that in a sec. Okay. All right. So, cool. Let's walk through this guy. Remember, this guy's multiplication, and this guy's an exponent. So I'm just leaving that 5 chilling. That 5 has nothing to do with the 8. It's not a 40. It's not 5 times 8 because the 5 is not in the power and the 8 is in the power. So this is going to be a 5 in front of, and I'm going to do the cube root of 8 to the 4th, right? So that's going to be a 5 times a 2 to the 4th, which is a 5 times a 16, so I get 80. For this one, it's a 1 over my 64 to the 1/3, which is the same as a 1 over the cube root of 64, which is a 1/4. And then for this one, it's a 1 over my 81 to the 3/4, which is a 1 over the 4th root of 81 all to the 3rd. So that's a 1 over 3 to the 3rd, or a 1/27th. Now look at that challenge problem quickly. The reason it's challenging, so why is this a challenge? Well, it's a challenge because 36 is not a 4th, so why is it a challenge? Because 36 isn't a 4th power of something. it's not a fourth power of an integer, right? Like 36 is 6 squared, but it's not something it's not the fourth power of something. So here's the trick. You ready? This is the trick. 6/4 simplifies. This can be simplified using algebra, right? 6/4, so 36 to the 6/4 is the same thing as saying 36 to the 3/2, because like all other fractions, that rational exponent can simplify, which means you're looking at the square root of 36, quantity cubed. That's a 6 cubed, which if you memorize that list of things I told you to memorize, is a 216. Okay? So that's it for 2.2. We'll start with 2.3 in the next video.